Quantum ghost imaging. This is an imaging technique used in various fields such as security and surveillance. Okay, if the places are obscured or somewhere where turbid media is there or the medium is opaque, so in such cases this technique of imaging, that is, which is known as quantum ghost imaging, these techniques are used. Again, in case of biological samples which are light sensitive, means if those biological samples are exposed to light, then there is a chance of damage. Okay, so in such cases this technique, means quantum ghost imaging technique, is used. So how this is done? With the help of quantum entanglement or quantum correlations, this can be achieved. Okay, this imaging technology can be developed, has been developed, okay, by the use of quantum entanglement. So by the help of nonlinear optics, photon particles are generated, a pair of photon particles. Spontaneous parametric down conversion, this is a nonlinear optic technique, and using this technique, which is in short known as SPDC, using this technique, a laser beam is passed through a nonlinear crystal which produces a pair of photon particles which are entangled, means they are correlated. You know the properties such as position, momentum, okay, velocity. So these are the properties of the photon particles and they are entangled or correlated. Actually, entangled pairs are generated by using that SPDC technique, spontaneous parametric down conversion technique. So now we have got entangled pairs. Suppose there is one object, okay. So what is done, if you have a pair of photon particles, you just assume you have a pair of photon particles. One photon particle is called idler and another photon particle is called signal photon and idler photon. The signal photon is sent to the object, means the signal photon is sent in the direction of the object, okay, and the another photon, which is known as idler photon, that is sent to a high resolution camera. That means the idler photon that is not interacting with the object, interacting with the object is the signal photon. Now after interacting with the object, a bucket detector is there, a bucket detector is kept where it receives, the bucket detector receives the signal photon reflected from the surface of the object. Okay, now a device is there which takes into consideration both the photon particles. Okay, by using a computational algorithm, the device can reconstruct the image of the object. How? Because the particles are entangled. The photon particles are entangled. The signal particle, position of that signal particle, means I am talking about signal photon, the position of the signal photon is not detected by the bucket detector. It detects only whether the photon particle is present or not. Okay, that is the function of the bucket detector. But the high resolution camera, that captures the idler photon, and the device that checks the pair of the photon particles. So by knowing the position of the idler photon particle, that device can reconstruct, or that device can know the position of the signal photon particle. Okay, can know this position of the signal photon particle, and that way the image can be reconstructed. So this technique has so many applications. I have already mentioned the applications in case of biological field, okay, where samples are light sensitive. Okay, again in case of material science, whether surfaces are so that scattering can take place. If you directly try to capture the image of those surfaces, or if the surfaces are light sensitive. Okay, again in case of astronomy also, say in between the earth and that object, say for example a star, the medium is opaque, or light available around that object is low. Okay, so in those cases this technology can be applied, though classical ghost imaging technology is also available, but robustness of quantum ghost imaging technology is much more as compared to classical ghost imaging technology. Okay, I'll make a separate video on classical ghost imaging technology. Here in this video, I am discussing only quantum ghost technology, quantum ghost imaging technology. Okay. So, what was done? First of all, an entangled pair was generated by using SPDC technique. Then out of two photon particles, one photon particle was sent to the object, another photon particle was sent to the high resolution camera. Okay, and since the particles are entangled, so by knowing the position of the idler photon particle, the device can know the position of the signal particle, and that way the image can be reconstructed. Okay, and resolution of such images are so high that it becomes valuable. Okay. Anyway, so this was all about quantum ghost imaging technology. Okay, so this is the end of this video. Thank you for watching this video.